Hi, and welcome to the Geometry Exit Ticket 32.1 video key. Let's take a look at what we got going on here. So we've got this little summary of the Theorem 60, parts B and C, which gives you all the proportions and that you need, all the formulas that you need. So we need to find y in this one. You may need a simple quadratic. So there might be a path that doesn't, but feel free to show me that if you see it. So we want to find y. We know what a is, and we know what x is, but we don't know what h or b are, and we certainly don't know what y is. So let's look at our options. So if we know what a is, so a squared would be y times c. Okay, well, y is y, and c is y plus 9. So we could say a squared equals y times c. Okay, and then we'll just start filling things in. So that's 6 squared for that, which is 36. That's for a squared. And then we've got y, which is just y. And c is y plus 9. Okay, so let's tidy all that up. So I'm going to have y times y plus 9, which will be y squared plus 9y, and that's going to equal 36. And I want to make that equal to 0 so I can start solving it. So I'm going to say y squared plus 9y minus 36 equals 0. So now I need two factors of negative 36 that add up to 9. And they're going to be opposite signs, so there'll be a positive and a negative. The positive is going to be bigger because we want to add up to a positive number. So 1 and negative 1 and 36 doesn't do it because that's 35. Negative 2 and 18 gets us 16. Negative 3 and 12 will get it. Negative 4 and 9 is too close, and negative 3 and 12. So we're going to say y minus 3, y plus 12, those are our factors, and that equals 0. Okay. So y can equal 3, and y can equal negative 12, because 3 minus 3 is 0, and that makes the whole thing 0, and negative 12 plus 12 is 0, and that would make the whole thing 0. Okay, but negative 12 is extraneous, because we're not considering negative dimensions. Okay, so let's, so then that means that y is simply 3. So y equals 3 units. And we're done with that one. All right, let's take a look at 5. With 5, we've got this pond here. We're trying to figure out how long this pond is. And we've got some survey equipment, someone named Slarpy and someone named Carpy, and it's all ridiculous names. But this is a legit surveying type of problem. I'm going to actually open up a little Google surveying tripod equipment. You may have seen people out and about with these sorts of things, taking measurements and so forth, and even, okay, and then you would, okay, pardon that interruption, but they are taking measurements of angles and distances. And so that's actually what's happening here. We got a measurement from here to here, and we've got a measurement from here to here, which is reported to be 3 meters. So we have this, and we have this. So this is our h, and it doesn't matter which is x or y. We could call this x, this y. I guess I'll call this y and this x, okay, because this will be a, okay, because it's opposite that. All right, so I've got x and y, and I've got h, and if you recall from up at the top way back in the beginning of this, h squared equals x times y, and we have y, but we have x, but we don't have y. So 6 squared will equal 3 times y. So h squared equals x times y. So that's going to be 6 squared equals 3y. And 6 squared is 36, and that equals 3y. Divide both sides by 3, you'll get 12 equals y. So y equals, and we are giving units here, so y equals 12 meters. And we're done.